Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up 3B.8 for texting crushes. So the number, you know what, let's talk about the directions. Use the scenario in the graph below to illustrate the empirical rule. You must show three standard deviations above the mean and three standard deviations below the mean. Well, real quickly, let's label our z-scores. We know our z-scores are going to be 0, 1, 2, and 3. And we also have -1, -2, and -3. And this goes to positive infinity, and this goes to negative infinity. And these are my z-scores. Okay? And for z-scores, got to remember this. The mean is always 0, and the standard deviation is always 1. That's for z-scores. We also know that this will be plus or minus 1, 68%. We also know plus or minus 2 is 95%. We also need to know plus or minus 3 is 99.7%. Okay, again, those are approximations, but those are closer every single time. You must clearly label the z-scores and the actual values. We did that. We have not done the actual values yet. So texting crushes, the number of minutes high school students spend texting or messaging someone they may have a crush on each day is normally distributed. So we have the normal curve with a mean of 90. Okay, so my actual mean is 90. So I'm going to write this off to the side. Actual mean is 90. So this is the z-score is my conversion, but the actual value was 90 with a standard deviation of 15. Well, this means every single one of these is going to be changing by 15. Well, 90 minus 15. Well, when I take my calculator and do 90 minus 15, I get 75. And I'm just going to run these down. 90 minus 15, 75. If I add, I get 105. So 68% is between 75 and 105, and that's plus or minus 1 standard deviation. 2 standard deviations, we're going to take that 75 and subtract another 15, and we get down to 60. And if I add 15, this is 120. So 95% of the text is between 60 and 120. Subtract it down another 15, and we get to 45, and this goes to 135. And once again, this goes to negative infinity, and this goes to positive infinity, and the red is the actual, all right, actual values. So 68% of all students crushed a text between how many minutes? 75 and 105. Because that's plus or minus 1 standard deviation, and we know that 68% is plus or minus 1. 95% go between 2 standard deviations, so plus or minus 2, which is 60 and 120. And finally, 99.7% of all the students with a crush between blank and how many minutes? Between 45 and 135. And remember, 99.7 is plus or minus 3 standard deviations. So we went all the way out there. Now I'm going to go ahead and show you the pretty graph of everything. Once again, please remember both z-scores and actual values go to negative infinity and infinity. These are my actual, and this is my z-score. So when we said 68% plus or minus 1, that was a 75 to 105. When we said plus or minus 2, that was 60 to 120. And when we did plus or minus 3, that was the 99.7, which is the 45 to 135. So use the scenario above to do the following. What percentage of students spend less than 60 minutes texting their crush? Well, first off, let's remind ourselves. Our mean is 90, and our standard deviation is 15. Now we know this is normal, so we need to draw a normal curve. And so when I sketch it, we're centered on 90. We mean to 90, and we want to spend less than 60. And I'm guessing if they're spending less than 60 minutes, they're texting someone else besides their crush. Just saying, just saying. Okay. So in this case, we're going to go ahead and go back and do a LUMO here. Second vars, norm CDF. So second vars, norm CDF, lower bound. Remember, this is negative infinity, so -9. Use the caret button to get to 99. Upper bound, upper part of my shading is 60. Mean is 90. And we set a standard deviation of 15 minutes. When we do that, we get 0.0227. So this area right here is 0.0227. And if we're writing our probability statement, which we should, is really the probability that negative infinity is less than x is less than 60. But we don't like the infinity part for math people, so we write the probability that x is less than 60. So there, that's what it looks like, with negative infinity being my lower bound. My upper bound of my shading is 60. And there's my mean, and there's my standard deviation, and that's my LUMO. And if I label that, it really does make a difference in my remembering. So the next one, what percentage of students spend more than 120 minutes per day on flirtatious conversations with their crush as opposed to with someone else? Not saying that that ever would happen, but sometimes it does. So once again, we know we have a normal distribution. We have a mean of 90, and we want to know the probability that it's above 120. And remember, we're shading to infinity, and mean is 90, standard deviation is 15. So once again, here we go. Second vars, norm, CDF, lower bound. Well, the lower part of my shading is 120. The upper part of my shading is infinity. So in this case, 9 raised to the 99th. Mean of 90, standard deviation of 15. And we end up getting 0.0227. Oh, and one other thing, our probability statement. We want the probability that x is greater than 120 because we shaded all above. So there it is. We have 120. There's our mean. Our standard deviation was 15. So this is my lower, my upper, my mean, and my standard deviation. And we get 0.0227. So the next one is what percent spend between 75 and 105 minutes? Well, you know what? It should be close to 68%. We're going to find out that it's not exactly 68%. 68% is rounding. But if I'd used empirical rule, I could have said, hey, by empirical rule, it's 68%. But I actually want us to take the time to calculate this and find out how close the empirical rule is to being accurate. So we're going to do a normal. Once again, it's normal. Not saying you're necessarily normal, but it's normal. So the distribution of texting is normal. And we have a mean of 90 and a standard deviation of 15. So my lower bound is 75, my upper bound is 105, and we're shading in between here. So probability that 75 is less than x is less than 105. So once again, here we go. Back to norm CDF. Second vars, norm CDF. Lower bound of my shading. What was the lower part? Oh, 75. Same as in my probability statement. My upper part, 105. My mean is 90, standard deviation is 15. And we get 0.6826. So we said our estimate was 68%, and what we actually came up with was 0.6826. So there's my probability statement, the 75, which is my lower, because this is my lower bound. This is my upper bound. And LUMO, lower upper mean standard deviation. And like I said, our estimate was 68% by the standard by central limit theorem, and what we really came up with was 68.26. So we're off by a little bit, but not by much. This is tenths, hundredths, thousandths. So we're off by 26 10,000ths. That's pretty small. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.